So welcome to the bolt joint design calculator. First of all, you will find the dashboard, where all the key performance indicators are displayed. These are the results of our calculations that we will see later. First, we begin with the inputs sheet, where the user enters all the project information. The bolt geometry can be selected from here, and the available bolts are also listed in the bolt database, which we can see over here. We have a very large variety of bolts. After that, some of the bolt information is automatically displayed, while the remaining fields are user inputs, such as the bolt length and the grip length. Then we have the joint and plate geometry, where different plates and different plate materials can be selected. Additionally, the user can enter the friction and lubrication information, the external loads such as the axial force, shear force, and fatigue load, and finally the design targets and safety factors that they would like to use. Next, in each sheet, there is an image showing the inputs that need to be entered. For example, here the bolt joint anatomy is shown, including the bolt diameter and the plate thicknesses, to assist the user when entering the required dimensions. As we said, the bolt database is the next sheet, and here there is also an image explaining all the parameters. Next, we have a material database for the plates, where a small selection of materials is available. The next sheet is the torque calculator. Here, there is a diagram explaining how torque works, and the torque calculator is shown over here. First of all, we have a bolt load summary, where almost all of these values come from the user's inputs, together with the bolt properties, resulting in the target preload force, which is automatically calculated. Next, the simplified torque equation is also calculated, and finally the required installation torque is calculated and displayed in the dashboard, as shown here. Then we have the preload calculator. Here, there is also a diagram explaining the preload concept. Additionally, based on the selected bolt, there is a recommended minimum and maximum preload. The target preload is set at 75% of the proof load, together with the corresponding margin to yield, and we can immediately see whether this preload is safe or not. These results are also displayed in the performance indicators. Next, we have the joint stiffness sheet. As usual, there is a diagram illustrating the stiffness concept. This sheet compares the bolt stiffness with the total member stiffness, which consists of the stiffness of all the plates, in order to calculate the joint stiffness ratio, denoted by C. This ratio determines how much of the external load is carried by the bolt and how much is carried by the clamped members. It also allows us to calculate the resulting clamp force, which is automatically displayed in the dashboard, together with the separation safety factor. Next, we have the external load analysis. The external load analysis uses the inputs that we previously entered. The applied loads are distributed among the selected number of bolts using the joint stiffness ratio that we calculated. We can also calculate the separation safety factor again and immediately determine whether the design is safe or not. Next, we have the stress analysis. In the stress analysis, we calculate the bolt stresses, including the axial stress, shear stress, and finally the von Mises stress, as well as the bearing stress exerted by the bolt on the plates. On the left, we can see all the bolt loads and the material properties that we entered. Using the axial force and the direct shear force, we calculate the combined von Mises stress. Finally, we calculate the bearing stress exerted by the bolt on each plate, which gives us the bearing safety factor. We are then able to calculate the bolt yield safety factor, the bolt ultimate safety factor, and the bearing safety factor for the plates, together with an indication of whether the design is safe or not. Here, for example, with a safety factor of 1.27, the result is considered a warning. Next, we have the thread strip check. Here, there is a diagram illustrating the thread geometry. Based on the selected bolt, we calculate the thread shear area and then calculate the thread strip safety factor using the applied loads and the material properties of the bolt. Here, for example, the design is considered safe. Finally, we have the fatigue analysis. In this analysis, we consider cyclic loading, which is the basis of fatigue analysis. Using the Goodman diagram shown here, we apply 3 different fatigue criteria. First, we consider the cyclic loading. Then, the mean stress and alternating stress are calculated, together with the material properties, in order to calculate the 3 fatigue safety factors. We also display the graph showing all 3 fatigue criteria. Finally, we have a safety summary, which brings together all the outputs and results from every calculation that we have performed. This allows us to quickly determine whether the design is safe, whether there is a warning, or whether there is a failure. All of these results are also summarized visually in the dashboard.